But I would assume that, you know, Brian did a great job at doing that in his presentation. And there was this nice distinction between reproducibility and replicability. And probably that could be a first question. Would you say that, you know, reproducibility is a necessary condition before you go to replicability? Is it really a necessary step? What do you think? Would you like to go first, Brian, naturally, and then we'll hear from Cynthia and Anna Maria?
Sure, I guess I set myself up for that. Is reproducibility, meaning like exact same numbers coming out, a necessary first step? I don't think it is. I think it's useful and good just to make sure that your code actually works and runs. And if people do want the same numbers out, they can do that just so that they can focus on other points of variation. If they're changing something about your framework, you can say, okay, that part is the same, and now I'm going to tweak this and do something different with it. That's very common. But replicability, at least in the Claerbout taxonomy, is a much softer thing. It's saying like, yeah, you can mess up the details, but the end result is qualitatively going to be the same. That's when you know you have a strong finding. And that is a better thing, right? Replicability is really what we care about. That's when we're making progress, like our epistemology is, you know, improving. But most of us don't get there. Like most projects aren't going to have that kind of robust effect. So it's a more attainable goal to aim for reproducibility, I think, but not necessary.
Okay, thanks. Cynthia, Anna Maria, would you like to add something?
Sure. Well, first of all, I do think that in terms of definitions, there's been a little bit of mess, right, surrounding these. I mean, Brian is specific about the taxonomy. Didn't ACM even switch the two terms around recently? Yes, they did. So there, anyway, if you talk about either of the concepts, probably ground clearly which of the two you mean. I would say, I guess it also depends on indeed what you're seeking to achieve with the work that you're doing. Very similarly, as I also said a bit in my talk last time, that I've been a bit closer now to software engineering colleagues. And I had a discussion 2 days ago with someone who tried to argue that you need continuous integration on anything you produce, which I like if it's something you continuously contribute to. But if it's something that you make just as a proof of concept once and you don't intend to maintain, I would say that the effort to put in that, of course, it's nice if you can, but it's a lot of overhead, where at the same time I recognize that, especially in fields like ours, people aren't always that trained software engineers who can write production-ready code. So I see with many of us that we also discussed it with Alex in the panel last time, that it might be quite hard for people just to get the scripts already right and decent. That's a big thing. And then getting them up to production quality is another thing. So if it's something you intend to maintain, if it's something you intend for the world to use, yes, then I would say get as close to it as possible. But be at the same time, of course, pragmatic, because there are so many things we have to look after also, as you heard today about data management, anything around it, the procedures as I was speaking about. So I'd say choose wisely depending on what you need and what you seek to achieve.
Cool. Anna Maria?
Yeah, I actually didn't think about these terms before the presentation, and then I was like, yeah, interesting. So I would say that from the evaluation point of view, reproducibility in a sense of like getting the same number, it's something that matters in this kind of a gradual improvement of the methods. So then you can like, you check that somebody's method gives the certain level of performance, and then you can go and say, okay, so now I can improve on that. So this is part of this, like when you want to actually compare the numbers. The idea of replicating something, this is, I see it more like, okay, you have a, okay, I'm just going to give again the acoustic scene classification example. So I have 10 classes, I do some acoustic scene classification, and I expect to get something like a 75% performance, and then okay, I kind of get it. So then if I go and try to do the same experiment, but I do go do different recordings, maybe like different conditions, but more or less with a similar distribution of the data. There we have different classes, different time of when they are recorded, but still the problem is comparable with the other one. So then I would expect that, okay, with the same system, I would obtain something similar. So in this respect, this kind of like verifies the sanity of the system.
Sure. I get your point. Just so this is clear, I should have said this explicitly. Please do feel free to follow up if you like. Okay, I'm just here to facilitate the discussion. And please, everyone, all the participants, do send us questions on the chat if you have one. Don't be shy. Okay.
I'd actually like to follow up on something Cynthia just said. Yeah. So about continuous integration, I totally agree. Like, not everything needs to get that kind of level of detail. But one thing that it does get you is, once you set it up, it should keep working. But as I mentioned, dependencies will change out from under you. That happens all the time. So you might write something in 2018 that stops working in 2020 because, I don't know, TensorFlow changed something. If you have a continuous integration thing that just runs every week, checks the newer versions of the dependencies and tries again, and it fails, you could be told, like, hey, this stopped working. You need to go back and fix it, because if people want to be able to use what you did, you'd at least want to do that level of maintenance, I would think. But otherwise, I totally agree. It's overkill most of the time.
Since you're mentioning continuous integration, there seems like for the same purpose, there could be, two alternatives, at least based on what you've just said, either continuous integration or, making sure that beyond code, you have runnable software, the whole required environment for, Docker container images, and using platforms such as Docker Hub or Colab or CodeOcean. How important is that next step, right? And what is your take on it? What is your experience with these platforms? Whoever wants to go first now.
Well, maybe I can go first there. We discussed this a lot in our lab. I will admit we haven't quite gotten at the point that we could do as much yet publishing things. And I see there that, of course, each of them also are moving concepts and platforms with Docker and the Docker Hub. Now there's been also there like a lifetime issue, right? That if you put something there and you don't use it for a longer time, it will actually disappear. So here, let's say I see lots of different efforts starting. I also see our university trying to get a bit more conscious about that, but also being very busy with requirements mapping on a university. It has many different requirements for different fields. If you can, again, I'd say do it. I would say, once again, that there wouldn't necessarily be one standard I'd necessarily promote. I do like Docker. I think it's the most general currently. But I could so much imagine that will also, again, change in a few years from now. So if it's necessarily something for eternity, I don't think so. But it's a nice practice, I think, that many people do understand. But that we also need to consciously train people in, because we don't do so much yet, I think.
Anyone wants to add something? No?
Yeah, I could. I was waiting for Anna Maria. So I think it again falls on this like reproducibility versus replicability continuum. Like, how much are you trying to reconstitute versus package up, right? Docker is trying to bundle basically everything. And there are tools that make this a little bit easier to manage, like ReproZip, which will actually like go into your code base, figure out what exactly you're using, and then build the container for you. That said, I don't use any of that stuff. And the reason I don't use it is because here at NYU, they don't actually let us use Docker. And the reason for that is because it requires privilege escalation on hosted machines, right? You basically need root access on the server to do the Docker thing, and they won't let us do that. So that kind of rules it out for me. And that's, particular to my situation, but I think it's a real problem. So for my stuff, I tend to go more in the direction of like use Conda environments, dump your version requirements in your environment and check that into your repository. And it's not perfect by a long shot. Like Alex's talk mentioned, if you pip install NumPy versus conda install NumPy, you get different results. And that has bit me so many times. I was really happy to see that mentioned. But it does get you more in the replicability kind of space where it's like, okay, does that detail actually matter to you? If so, why? Think about it. If not, that's good enough. So that's what I've been using.
Yeah, plus about conda, the problem sometimes simply might be that for some packages you use pip and then you have a mix of pip and conda packages, and that export of the conda environment won't get you the things. And yeah, I see the problem you might have, when it comes to systems administration, but in my opinion, really Docker containers are great. I agree, because typically they avoid, once you're familiar with the whole thing, they tend to facilitate, at least the freezing of the whole environment becomes really, really much more reliable. Anna Maria?
Yeah, I don't have much to say on this, but I'm just gonna mention that basically in the D case, releasing the baseline system, so we had to use the Docker, like we had to, in order to mitigate the complaints from the participants of like, so why my number is different? But I mean, it was like a 0.1% different, but when some people are fixated on it, and it's like, okay, your baseline system, you say it obtains this like performance, like why mine is different, and like it does not matter. Yes.
But that's the thing. Yeah, that's probably a nice follow-up question. That's the thing. Okay, you said earlier that we're all winners and etc. And challenges are there to stimulate research. But indeed, for many, you know how it matters. It could be game changers for some PhD students, for instance, who basically then can state and say they were the winners of that edition of DK. So these things matter. And there was a quick discussion on the fact that for some tasks, there were different metrics being used. And so basically, I think in the end, you for many tasks, you managed to combine them. Can you say more about, any thoughts you have about combining different metrics, especially in situations where they want to agree? One metric would give system A as the best, and the other would give system B as the best. In the context of an evaluation campaign like DK's, how did you deal with these things?
Well, okay, so basically in tasks where I was part of the organization, we just went like, come on, we pick one and stand behind it and face the criticism. Of course, there was a lot of criticism. Like the problem is that we, for the sound event detection, for example, we chose this error rate, which is like, okay, it represents you understand very clearly what it means. But then some years ago, it's like, okay, when you were doing the optimization and there's like, some normal students come and they start building some machine learning thing, okay, and then they like take the functions and this and that, and then there was in 1 year so clearly because with the default way of optimizing, it was optimized by F-score, and then if you order them by F-score, you see huge F-scores, but then nobody looked at this option that, hey, by the way, we are measuring something else. So this is also a problem. So then if you, like in the next year, they caught up with it and like, aha, wait. And then they started kind of calculating at intermediate points the error rate, and okay, suddenly the situation changed. But what I'm trying to say that in some cases, we just like, okay, we picked one and this is the ranking metric. But then, for example, the first time when the sound event detection and localization was organized, there was like this uniting two totally different fields. So one is the localization, which uses certain metrics, and one is the detection, which uses other type of metrics. And then they are totally orthogonal. And the way they thought about measuring is like, okay, we measure this and we measure this, but for each of them, they actually had two metrics. So F-score and error rate and some direction of arrival, something and something else. So it was kind of like okay, so what do we do? So the way we kind of united them in one was that we ranked the system by all of them, like separately, and then we did the cumulative rank of the methods. So okay, it's like extremely crude, and it was kind of an ad hoc, like okay, let's just like try to put these things together. It was a bit of an afterthought in a way. Yeah, but and then we started discussing that, okay, can we measure this in some smarter way? And then we tried to kind of propose some sort of a metric, which was then later used. But that was the first attempt of combining metrics, which are like totally orthogonal. Yeah,
it's not an easy
yeah.
thing to do in general. I don't think it's an easy question indeed. Yeah. Okay, I'll be alternating between specific questions and more general ones. This is a question actually by Vincent. Let me ask it, and I guess you'll see what he's expecting from you. So Vincent says, suppose you ask a student to reproduce some computational results from a colleague of yours. After 3 months, they come to ask for help. The code runs, but the performances are near nowhere those of the original publication. What do you do? I guess we're looking probably for a procedure, a process, right? Something, the steps to take. Who wants to go first?
I can take a stab at it.
Okay.
So the first thing that I would do is try and understand if, okay, the results don't agree, but do they make sense independently, right? So start doing some qualitative error analysis, like was mentioned in the previous talk. You look at the predictions. Is it just messing up everywhere? Is it messing up for certain classes? Are there certain types of examples that are causing you trouble? Is everything off by half a second? Like, these things do happen just because of data issues or code mistakes or whatever. So that's always the first step. And even if you're not trying to reproduce something, if you're just trying to understand what your system does, like, you should do that anyway. After that, if you convince yourself that your code is correct, your data looks good, you don't have any bugs, then I would probably go talk to the original authors and say, like, hey, we're trying to replicate this. We're getting these results. Did you see something similar? Here's our code. Can you try it on your data in your environment and see if there's anything that raises any flags? But I think the first step for me is always qualitative error analysis.
Okay. Cynthia?
Okay. Oh, sorry.
Or Anna-Maria, as you like.
Yeah, we actually went through these kind of things in slightly different scenarios. So that, for example, with the D case, we are evaluating the system outputs of the participants, and then it was like, okay, you have they are also sending some information about their system, and then they report their performance on the development data set, and then you kind of like see the evaluation. So like, okay, you can check for generalization, and so then it had happened not just once, that when evaluating the system outputs, it's like totally random, like it's a random guess, and then you go like, okay. And we are actually contacting, it's, I mean, our purpose is to do science. So we contact the authors and they say, look, I think that there is some sort of an issue there. So many times it was like just the indexing thing. Like there was like a file name with one, like, where do you start the count? So that was the only problem. And then when they fixed it, like it's like the silliest mistake. Yeah. So it goes like that. Or then, for example, noticing from somebody else's work that they actually did a mistake. And, of course, it's kind of like if you realize that somebody else has made a mistake and you're trying to reproduce it, and then you discover something, of course, you write them an email and you say, look, I think this is what happens. Can you please check? Yeah.
Yeah, I would agree with what has been said here. So make sure first, indeed, in your situation that indeed things are checked, and if not, get in touch with those people. It can very well be, unfortunately, that this indeed happens much more often than you would hope it would. And there, I just also want to re-emphasize that, as Brian was also nicely laying out, 10 years ago, 15 years ago, we didn't think about this at all. We didn't have very good ways of handling this, versioning this yeah, especially not in these types of worlds. So it will probably not be uncommon. And especially what I also discussed in my talk, if you might even have same task but different data set, lots of funny things will probably happen. And you think you solved the task and you didn't quite. So it is something we are going to face a lot. I do feel I've seen around me this happening a few times, also sometimes with people not responding, also actually with some allegations or actually indicators of deliberate cherry picking, if not even fraud. I've seen that as well is a point of very much concern, especially if the authors are powerful. It happens. But also regarding this, I do see lots of institutes and generally the whole community, I think, moving towards more transparency overall. So don't be too afraid if you're really sure that something isn't quite what it should be to actually raise that. It is okay. You will typically have boards for that. We have now also an integrity board in our university, for example, looking at these types of matters. So yeah, it will happen probably.
There's actually something I want to add, because we are talking about it like, if you go to somebody else who made a mistake, but this is not always the case. It's like also owning up to your own mistakes, because you might publish something and then somebody will, or even without anyone pointing it out to you, you might notice later when you try to develop it further that, okay, you made some like totally stupid thing there. And it's something like, of course you have to tell, and just like, okay, it's wrong, but here, now I fixed it. So yeah, it's not such a big deal. I think this is also part of the integrity, like academically, scientifically, like you just have to say, yes, I did make a mistake. And yeah.
And I must say that personally, I think indeed it's much better than to just be transparent and not try hiding. I've seen reactions sometimes being awkward. What I'm hinting at here in Delft, we recently had a bit of a scandal surrounding one of our quantum physics groups that was looking for the Majorana particle. And there were some discoveries made back in the days that were like potentially Nobel Prize worthy. And ultimately, there have been allegations of at least that being irreproducible, if not maybe fabricated. They couldn't, when they investigated, get to the point of actually claiming it was a deliberate fabrication. So there, they couldn't necessarily like do a formal punishment, but the article has been retracted. There's been a lot of discussion about it. But you saw there that because there were so many stakes involved, the authors were very, very hesitant initially with giving more transparency, and that really didn't do their reputation any good in the broader society. So I definitely think the movement is towards more transparency, and people have really been shouldering that, especially the younger ones, which I think is really nice.
Actually, we should all remember that it's always possible to publish, errata to a paper you've previously published. That's totally possible, and it's always much, much better. Okay, I have a good one by Mathieu. Career-wise, is reproducibility a risk or an opportunity?
Oh, that's a nice one. Yeah, I think sadly this does depend on your environment, I think. So what I can say is again that I see a lot of people, especially the early career people, really wishing to push for this. At the same time, of course, I know the academic systems, and some are rougher than others, and some won't give you the opportunity if especially your surrounding management just doesn't see this. So there it very much depends where you are. What I can say, I think generally in Europe, we're pretty good. I've seen already, of course, France has had a very good open access policy. In the Netherlands, there's now a big discussion on what they call recognition and rewards, where they're pleading for not only having the high ranking papers counting towards your promotions. There are lots of discussions of what else to look for. People say impact is also contributions on software, contributions on data, contributions that are collaborative in nature. So they're really now finding ways to put that formally as part of research assessments. Also the DORA declaration that has been signed also really moves towards a much more holistic view beyond just outputting papers that are in fancy outlets, and then you don't even care if they're read as long as the outlet is fancy. So there is this movement happening. of course, in practice, I do still see, even in the Netherlands, where they now try to push this, a lot of hesitance around me with people saying like, but what do we measure then? And yeah, it will remain awkward for a few more years to come. But at the same time, the traction is there, the movement is there. It's been moving so much more forward since, again, 10 years ago. And I think academia is a very historical syrupy, fossilized thing that moves slowly. So the amount of movement we've seen already, I think, is really interesting. And in that sense, I'm positive.
Yeah, for example, here in Finland, there is like a very much push for open access publishing, and the university. So our university, they have this kind of like open science policy, and like everything that you publish, if possible, should be at least green open access. So like the thing that you can do is to just upload it to the university kind of library repo, for example, or like we are putting the publications to our websites. But they are kind of like also the like a funding opportunity. So Academy of Finland, they were like, so funders, they are requesting the open access. And of course, like EU projects, like all the projects which are funded by EU, they request if possible. So of course, it doesn't apply for medical data and things like that, but they want open access, like open data and open publishing. And if I'm not mistaken, also the kind of like funding of the universities, like the funding that the universities here receive from the government is kind of like influenced by the number of open access publications. Yeah, so they are really counting. So it is not necessarily like on a personal level. So on a personal level, maybe, you know, if everything you publish is open, then maybe it's easier, like you get more citations, or like your work is gets more spread or something. But on a level of where it counts, so it counts on this kind of like aggregated at the university level, at least here.
Yeah, it's a clear trend indeed in Europe, I think everywhere. Brian?
Yeah. I definitely agree with Cynthia's point that, like, yes, it's an opportunity if you have the means to make use of it, but not everybody is in a position where it will be rewarded, or, you know, some places will reward that more than others. You know, short PhD programs are a good example of rewarding quick publications, make progress, staple it together, out you go. And some of this stuff takes a lot of time, and it takes time to, you know, get a sense of what software is actually needed to make things reproducible. How do people want to use things? How does it best fit with, you know, the broader ecosystem? And the same is true of data sets. Doesn't always fit with your particular situation. But what I will say is almost everything in Librosa, as an example, is in some sense a replication of something else, right? We spend a lot of time reproducing and replicating like MATLAB functions that a lot of different labs are using to generate their features, or methods that were published in different papers. And we worry about getting the numerical precision to match. You know, if you configure it just right, will you get things in the eighth decimal place to be the same? For the most part, yes. And I learned a hell of a lot doing that, like way more than I thought there was to learn about these things. So it's paid off for me. And I think it is a good learning experience for people to go through that, at least a little bit, if not, you know, to that scale. But in terms of being rewarded for it, sometimes it pays off. But more often than not, it's just like, write the paper and get on with your life.
Actually, this resonates. Yes, go ahead, please.
So indeed, to let's say give a completely opposite example, and something I've personally really found very hard. So I, in my talk, also highlighted some work of Jae Kim, my recent PhD, who now is a postdoc with me in the group. He is from Korea. And we did have this discussion in terms of his work, which looked a lot at frameworks for reassessing whether things actually went the way we thought they were. That those were not typically recognized as novel contributions with novel insights, because we were redoing a lot of work and systematically looking at it, which we still thought was a useful contribution, but it was not a new algorithm, of course. And there as well, we saw the issues both with getting it seen, but secondly, also, at some point he came to me and he said, you know, in terms of future, and I also discussed with him, what do you want to do after this PhD? Would you like to go home to South Korea and go to a university there? And he effectively said, if I want that, I know they have a point system there, and they just count how many publications I have in certain types of places in the last certain amount of years. So that would mean that now I have to crank out NeurIPS papers that I actually don't want to write. And then I told him, like, are you sure? Because it does mean that you can't actually go home to academia in your home. And he said to me, yes, I don't want to go into such a culture. And I said, okay, then we don't do it. But for me as a supervisor, that was a very hard call to make. I will confess. So it is true that not all places are yet there. And we have to see what happens in the future there.
Yeah. Can I still jump in on this one?
Yeah,
because
sure.
So much of the effort that we are making for this decades challenge, there's like, of course we have publications and we have some, like, we are still doing some things there, but there is a lot of work which is behind the scenes, which is maintenance work. It's maintenance, and it's kind of like a building up the community. So you are giving some baseline, which is not the fanciest kind of code, but you want, like, okay, this is a baseline. It's not supposed to do anything super fancy. Then all the data sets, collecting the data, that is like a very lengthy process. You need to have the funds for it. You need to, like, you know, annotate it. Who's going to document it? There is so much kind of a work which is needed, and it does not bring you all that, like, okay, like, of course, I could have used that time to do some my own research and write my own, like, write some paper, and that will bring me maybe more to my CV than this. So this part of, like, building the community, it is rewarding, but it is in a different way. So yeah.
This resonates very well with another question by Mathieu. That is, okay, so reproducibility comes at a cost. This is what we're saying. How do you balance that cost on a daily basis? I mean, are you aware of the time you're dedicating to it, and is it, you know, balanced enough?
I think that I don't know about the others, but at least I can say for myself that being an academic has this kind of flexibility. And flexibility often means that I can have some easier times when, you know, I maybe not work with, like, such a extreme speed, but there can be also times when there's, like, day and night, and the free time blends in with the work time, and there is still something always on the back of your mind, and there was one more task that you have to do. So I don't think we are counting. We're not counting it. We just, like, after some time, for example, we looked back and we like, whoa, there's there is a lot of work that we did, and it's like, when did it happen? In between, I think, in between all the lecturing and the other things, and this research and that research and writing funding applications, and then you still do a bit on this one every now and then, and it builds up. Yeah.
Ryan, would you like to add something?
Yeah. So, you know, these kind of behind the scenes efforts, they don't replace the research work, right? We still have to do the other stuff because not everybody cares about the behind the scenes stuff. There are a couple of ways that it pays off, though. So one is, you know, if you do it well, it does help your reputation in the field, and that does matter for other behind the scenes stuff, you know, like letter writers, references, all that kind of thing. You know, if you stick in the field long enough where that is a factor to worry about, it does help, I think. More short term, if you set it up right and you can rack up some citations from putting out software tools or data sets with DOIs that people actually do reliably cite, which they won't, by the way. If you just put out a data set with the DOI, they're not going to cite it properly. Same with the software tool. It's just the way that things work. But, you know, enough people do that it does help. But where it really helps for me is making my own life easier, because I don't like writing the same code over and over again. I want to write a tool once and use it. And I've done this kind of thing where I, you know, write a train test split. Like Anna-Maria was talking about how that is a subtle thing to get right. And it is. Scikit-learn comes along and makes a tool that does it. And it's great. Use that tool. It solves some of your problems. It does not solve all of your problems. I actually went in and added stuff to that particular part of Scikit-learn to do this kind of stratified group shuffle split thing, because I was doing it so often on my own that I thought surely other people have this kind of problem. Once that's there, Now I no longer have to write that code. It makes my life easier, makes my students' lives easier. So there is a cumulative effect to getting your kind of tooling up to the point where it's easy to just, copy over and not have to redo things from scratch. But it's really hard to measure that stuff. I have no idea how to do it.
I mean, that at least something, tangible, right? You see an ROI on that investment you make and all that time you spend, and you see it immediately, because it makes your life and your students' lives so much easier. That's something really tangible, I think.
But then other difficulties will fill that vacuum that was there, right? So it's not like everything is easier. It's just other things are difficult now. So at least in my experience.
Yeah, I definitely think that there is no single best practice there. I think what I would advise is to make sure you're not alone. Make sure you have an audience, or preferably also backing around you. Backing from your supervisor, very, very, very important. What I'm also seeing now in that sense, again, now I have the privilege of being tenured. I know in terms of my contract that I'm safe. I don't have to prove myself that I'm worthy of my university. Then as a consequence, if university claims to want to do more things with integrity and reproducible aspects, I now have a reason to say you asked for that. So now I'm going to try, especially if in the Netherlands they want to look at this, which means I actually currently am doing a lot of policy work, which is not research, but which is a lot about actually shouting at the government, telling them that they are not actually needing what they ask from us. So different type of story, but again, relevant, because in terms of future infrastructure and what my students can do, I do think it will pay off at some point. And I happen to now be at a point where I can afford that. But that's, of course, something which I need to discuss with my manager there too, because I'm not spending the time on other things indeed. So this is always a balance you have to make, especially when you get into a staff position. If you're a PhD, of course, your main focus is your dissertation. But regarding that, make sure to ground also with your supervisors what they expect regarding the dissertation. In my experience, often students have a bit of a monolithic view on it, which might actually in practice be a little more diverse. So I've seen people who need to do collections of contributions, others who need to really write one big monograph. Depends also a bit on your institute. But make sure you have clear expectations managed on that. And if you know then what the minimal requirements are to get there, make sure you are there, make sure that you meet what is expected of you, and then take the rest of time to invest in these things you find worth investing in.
Okay, thanks. I have a question about, data and models, which is something we've alluded to earlier, but probably not enough. Clearly, there's a trend, a nice one, where basically we can easily download big models, right? Especially, deep network parameters. What do you make of the fact that sometimes one cannot reproduce the training of such models, either because the data is, not available, or merely because of huge computational infrastructure that might be required to be able to recompute those models? Okay, is that a problem at all? What do you think? Who goes first?
I can go. Yeah, so, well, I don't mind that someone else took the effort to actually spend the compute and the time and the governance to do that. And I'm not quite sure if in a public university with the facilities I have, if it's even worth for me to go through that whole process. It will be much more expensive to me comparably than it might have been for these other parties. So I think it is acceptable. Of course, it does mean that I wouldn't necessarily trust, if I run it locally, that I actually get the same things out. And that probably, indeed, in terms of how integer the model is, you might not really be able to tell, of course, beyond what is reported on that. So you always have to be a little careful regarding that. But that I cannot fully go through that whole training stage myself, yeah, for me, I think it is an acceptable trade-off.
Yeah, I would also say that practically you would go and trust that it was trained and that you can use it then you just move forward from that point on, that it is trained. Because if it's like this kind of a huge model, then why use all that computing power to retrain it, reproduce it? Do you have a reason actually to retrain it? Why would you want to retrain it? If you just want to kind of like, okay, mostly you use them for some transfer learning. So then you would just employ these things and add something to them. So then it kind of like unnecessary verification step. And of course, if you are very suspicious, but why would you be for a kind of a model? So it's of course good that you have the data available. So if you really want to, and if you want to make some changes to the actual training process itself, then fine, you could do it. But even if you have the resources, like, you can use them better, I think.
Especially given, you know, the carbon footprint that might represent, which is something we don't always, at least not enough, take into account. But
yeah, this starts to be discussed recently, of like especially for this language model for like BERT, and yeah, they are crazy. So then of course, why would you want to redo that?
Mm-hmm.
Yeah, I think the situation isn't so different from any other piece of software, right? We build small layers on top of incredibly deep stacks, right? I write a Python library that sits pretty high up. You write something that sits on top of that. I'm sitting on top of scikit-learn, SciPy, NumPy, LAPACK, BLAS, and then all the hardware stuff. And I'm not going to go and rewrite BLAS from scratch. Have you looked at that stuff? Like, I am not that good at Fortran. Like, it's just not happening. And we kind of accept that. We accept that the people that develop and maintain that stuff know what they're doing and do a good job. So there is a difference, though, in that those tools are kind of deterministic, logical programs with formal math behind them. And for the most part, they're pretty rock solid. You take something like, I don't know, VGG-ish, or in the language case, BERT, GPT-3, whatever. Okay, those things are also sitting on that deep stack, and then have a whole other deep stack of processing and this other injection of knowledge in the form of data. Depending on what that data is, it may or may not be beneficial to you, right? Those pre-trained models are going to have biases, they will have quirks, they will do strange things, and they're opaque in a way that like LAPACK and BLAS are not. At the end of the day, I can crack open the BLAS source code, and with enough time and enough resources looking in math books, you can kind of figure out what's going on and convince yourself that it works. With the pre-trained model, not necessarily the case. So there is this kind of transparency and accountability aspect to the pre-trained models that is worth considering. But that said, I'm happy to run with a pre-trained model if it suits my needs, and it saves me from having to do everything from scratch. So, it's on balance, for the most part, I think a good thing, but some caveats exist.
Agreed. There's a question, I might have missed it, but I have the impression that we didn't address it at all through the different talks, which is the question of licenses, right? Software licenses, I mean here. Have you thought about it? How do you choose the right license for your software? Are some licenses better suited when it comes to ensuring reproducibility?
I'll jump on that. I'll drop a link in the chat. It's called choosealicense.com. And it's just like a simple interface that helps you navigate what license is appropriate for a project. Okay, fine. That's useful if you've never seen any of these things before, but practically speaking, if you're releasing software with a license, it's because you want people to use it. So the things to consider there, the main one is, what other software do you integrate with? So I work mainly in Python. Most of the scientific Python stack is in a BSD style license, which is extremely permissible. So that's the license that I use just for compatibility. Actually use a slightly simplified version of BSD. It doesn't matter. If you want to know what that is, go to this website. You can read about what it guarantees. But I have colleagues that work in R, And in R, the convention is everything is GPL licensed or some variation of GPL licensed, and GPL is viral. So people go with GPL licenses there for compatibility. And that's really the determining factor most of the time in my experience, is just what do you need to integrate with. Once you start to get involved with like commercial aspects, like or if you're doing this in conjunction with a large corporate entity, then you might need to worry about like Mozilla license or something like that, or Apache license, just to like limit liability and talk about who owns contributions and things like that. But for the most part, I go with BSD style license and don't look back. Probably the university doesn't want me to do that, but shh, don't tell them.
I won't, and no one will.
Yeah, I was thinking a bit about that. I actually started checking like what kind of license do we have for this kind of like baseline system and such. But I actually don't remember. But anyway, at least for the data sets. So like they are like openly published, but for research, like not commercial use. So the problem is that we signed this agreement and the university owns our work. So the university owns that data practically. We're giving it out for research, but there was like a nicely crafted license text there from a lawyer. And practically, if some company wants to use it, then they have to contact the university and then they will discuss and they will license it for a fee. So the university owns it. It's not ours to give out. So there's the only kind of like, there is this agreement that yes, we can give it out for research. So, okay, I'm still gonna look for like what is with the code, but my suspicion is that it might be the same situation. Yeah.
I think Mathieu wants to ask a question, and maybe Cynthia would like to add something.
Yeah, it's just a precision. That means that for example, Mitsubishi or Philips want to participate to decades, legally they should contact your university.
No. So the decades participation, they can do it, but if they want to put it in a product, or if they so like if they want to use the result of their participation for something that they will commercialize, then it's like then they have to contact us. Yeah.
Okay, thank you.
Yeah, this really depends on institutes and their policies, I think. So in Delft, we do have this interest in valorization, but it tends to, in terms of stricter licensing, really to be on hardware. So with us for software, there isn't so much guidance. And generally we're told like, you can't really protect and lock it down, and you shouldn't either, I think. So typically there we would be quite open on it, but indeed then looking at the surroundings. So we don't necessarily have a default plan there, but as Brian says, if you're in a GPL-ish environment, you will have to go by that, which also means that if you want to maybe put it in something that you wish to close, then maybe that's not the wisest choice. So there are these different considerations to make, but they're really, really project dependent and dependent on the surroundings around it.
Makes sense. Yeah, I guess that really depends on local policies in each university, and clearly there's this question of how to reconcile the requirement of creating open software, open data sets, and university valorization departments having other agendas. And there's hopefully always a good trade-off. Other questions by the audience? No, okay. I have another question about version control. Okay, I think there's no question that the software version control is inescapable today. What about data version control? Do you have experience with that?
With us, we've been thinking about it a lot. We haven't yet actually implemented it. And generally, I again think the concept of data versioning is probably also very problem specific. At what point, how you want to treat it, if it's a one-shot thing. I guess if you make a benchmark, there is a clear version release point. Well, if you are in process of acquiring, maybe you're not. If you have streaming conditions in a project, it's even harder probably to really fix anything. So there are lots of nice propositions on this, I must say. And even I recall Geoffrey also in the past publishing some work on this. There have been also in our field lots of ideas about this. I think currently the best thing to do which maybe from a university we recognize is more along the data sheet side, what Brian also referred to. So at least clearly documenting also just sources and procedures surrounding that data, more than the version changes on the data. But again, if certain content requires for you to fix things or to have stronger signatures on things or protections, of course, then you need to look into that. So yeah, that's at least my perspective on that.
Thanks.
Yeah, my experience is kind of mixed in that nobody really does it, right? Like it's things that we've talked about doing or want to do. Some data sets are hosted in GitHub and you can submit pull requests, and maybe the maintainer will merge them and maybe not. I've had it go either way about equally often. And whether that manifests itself in a new release of that data that people then use as a different data set than the previous one, it's, yeah, still, I think the jury is out. But like I said, it's good to establish a procedure, kind of like GitHub now will try to nudge you towards having a contributing guidelines document on all open source projects that says like, here's how to report bugs, here's where to go if you have questions. Have that for data, why not? It costs you like literally 20 minutes to write down that document, and it will save you a lot of procedural headaches later on. So I'm for it.
Thanks, Anna Maria.
Yeah, like we've sometimes had to change some metadata for the data. So there was some complaints, you know, like, oh, there's this kind of noise, and how does this influence the kind of actual task that you are giving us? And then we did some extra annotations. And so, for example, in Zenodo, all our data sets are there. You can always so like you replace the you can replace some of the files, but not the data itself. So like the audio files, those are like, you have to contact them if you want to replace anything there. But then if you are just replacing this kind of like some metadata there, then this has like, okay, then it's like, okay, this is the version 2. So yeah, it's kind of inbuilt there, but you do not have the freedom of doing whatever you want there. So it happens sometimes that you have to actually contact them.
Yeah, it seems to me that we're still in a phase where it's mostly ad hoc procedures and you know, nothing really systematic being done yet. Let's go back to evaluation. There's yet another question by Mathieu. Thanks, Mathieu. So he's asking, and please feel free to elaborate on this, Mathieu. Is there a way to make validity and stability studies systematic, or does their design strongly depend on the task considered?
In general, I think that it matters on the task. So because of course, if you manage to create a perfect system, then it doesn't matter, you know, then you get the best performance, whatever you measure, then it's, you know, perfect. But it never goes that way. So you have to optimize for something. And then what you optimize for depends on your problem. So do you accept errors? Do you want mostly some kind of errors that is there something that you want to avoid absolutely, or, you know, like what matters for you? And this is then kind of dictating what you are measuring. So the task and the way you set up your system, the way you optimize it, and then what you are measuring, they are related. Of course, one can argue that, okay, if you are measuring what you're optimizing for, then is this system kind of like universal? Like, well, it will not be if you start measuring something else in its performance. But then does that other measurement matter for your problem? Maybe not. So it's hard to optimize for multiple things at the same time. Like in this kind of like sound event detection case, F-score goes up, error rate goes down. So then what do you want? Do you want a better F-score? Then you go for that. Like it's as simple as that.
Yeah, I do think philosophically we have a bit of a paradox there in our field, right? That's on the one hand, also related to this discussion, some one metric, more metrics being the winning system or not, that we really like to think of universal, general looking solutions that are just better, where probably in practice the insight might be on knowing a bit more specific, like, oh, we're good at this, but not good at that with this type of method. So I'm not sure if that's even an academic artifact in a certain thing that we wish to have more of a holistic approach to something really big. But at the same time, as Brian was arguing, we often look at very abstract questions in the first place, where there are so many subfacets of all of those, and each are really worthy of good study and might need their own takes in terms of their evaluation. And I guess our knowledge advances best and we're most transparent about it if we just agree on that this is that part of that whole thing. So I would also argue it is quite domain problem specific, and even the validity questions I was speaking about, that is very explicitly domain specific. And also even looking at Bob's work on the horse is also very explicitly saying a horse is a horse for a particular problem, but maybe not for another. Your system may be perfectly fine optimizing for something in a particular evaluation realm where that is a completely erroneous system in another context. So I guess being also transparent about that is completely acceptable and makes things more transparent.
Thank you, Cynthia.
Yeah, I think once you get down to it, it really will be problem dependent. I do think there are some commonalities across most of the problems in terms of methodology that we can kind of standardize on. Nothing fancy. There are things we do all the time, like, you know, designing train test splits and accounting for stratification and that sort of thing. I think that is kind of universally applicable to all of our experiment setups. The way that we report scores, you know, we often will write an average number and leave it at that, and then bold the highest number, even if it's only highest by like the third decimal point. Like, that's obviously bad, right? Like, we know that's bad. Let's stop doing that. Let's actually report more descriptive statistics. I think that applies universally. I think there are a lot of these kind of practical nuts and bolts things that could be better standardized, even if the details will be different. But, you know, that's a whole other rant that I don't really want to go on.
Makes sense, indeed.
So one thing that we were trying to do, for example, in some previous editions, but then we became a bit lazy in the decays, that we actually published the system outputs that the people have submitted. So that is something that you can do. Like, then you are totally transparent. It's like, okay, I measured F-score for my system, but here it is. There's my output file. And if you want to measure anything else, just do it. Because this is the idea that, okay, what if somebody comes up, you know, there's development happening all the time, and somebody comes up with something else to measure, and then they want to compare with a system which was published, you know, last year. And this is the easiest thing to say, okay, hey, there's the system output, and you have exactly the same format, so you measure it the way you want it, and then you can compare it. So that's also part of reproducibility. See, I forgot even to mention this.
I like this, and I agree with you. For particular tasks, right? One sometimes ends up coming up with a new metric, you know, especially in tasks where there's some level of subjectivity, where you decide that you want to penalize differently, typically some types of errors and not others. And yes, having access to the outputs would be really the ideal thing. Otherwise, I would guess that this could lead us to the ultimate question in machine learning, which would be learning the metric that you should use.
There are many studies like this. There are many metrics which are learned. Yes. Yeah.
With some objective, you know, that's the thing.
Yeah.
So, yeah.
Yeah, I'm so happy that you mentioned this, though, that keeping your outputs around, right? That doesn't really cost much to do. And it makes so many things so much easier down the road. A lot of the studies that I've done have just taken previous outputs of a different system and then looked at different aspects of them, right? That's so helpful. And I think it points to the importance of having like good standardized data formats that all models can speak, so that you don't have to write so much glue code to make them talk to each other. This is why I care about JAMS. Even if JAMS is not perfect, it at least tries to solve that problem well.
To follow up on this, what would you think of a new, not format, but say a new addition to conference proceedings, and you know, say paper submission systems, where there would be a standardized way of submitting your results for different tasks which are known. Would that make sense? Would that be reasonable?
That's Murex, isn't it?
No. Well, you'll be submitting really the the outputs of a classification system with some standard, the outputs of a regression system, etc. You see that.
I worry that it would be a little Procrustean in that you're trying to force things that have a lot of nuance to them. Like, it's never as simple as here's a table of numbers. There's always something interesting that you're trying to do. Otherwise, it's not a very interesting paper. And I worry that trying to force things into a too standardized of a format will hurt more than it helps. But I do think having a flexible way to collect those kind of intermediate artifacts is super helpful, and is actually something that I think Julian Urbano and I have talked about trying to set up for years and have not done it, but we should.
You should indeed. There is a question from, two questions actually. I'm very sorry for mispronouncing your name, Maciej, I'm sorry, Slivovsky. So the question is how to give credit to open source contributors when you submit papers, I guess. That's the first question, and the other question is, of course, measuring impact is important in many institutions, and counting citations, etc. So can we think about any better way than publishing papers in order to give value to software and repos in general? Who wants to go?
Yeah, very good question, very difficult question too. I mean, again, I've seen locally both a lot of interest and movement, and at the same time a lot of hesitation about these matters. So one thing which is also really tricky is that many people in my department are computer scientists, so they typically indeed wrote and maintained their own stuff. At the same time, if we go more interdisciplinary, that's not always the case. So some people have needs for support there, where then the developer needs to be a supporter. And whether that's a supporter role or something that you can just do in your main time or not, or where you have to be trained on, I do see a lot of disbalance there, to say it that way, where indeed not everyone has naturally the resources to be able to then be supported. The question also is, if there is a supporter like that, they carry part of the merit of the work, and that indeed isn't always something you can easily put in a traditional type of paper setup. One thing I've seen happening is in the acknowledgements to very clearly give shout outs. I think that's now the standard way. If it's people in your team, you can co-take them as co-authors, of course. Beyond that, again, I very much think that champions are needed for these types of resources. I do think Scikit-learn did a very good job at that. Coming with an initiative that was open, that many people bought into, where they could also show, look, we're used by so many people, we are important. Not everyone has that opportunity. Obviously, our local libraries won't quite get there probably, but I do think in terms of credits that indeed, if people are explicit about that, at least acknowledge, or wherever they have the opportunity to mention that these things are important, to just make sure you're very explicit about it. That's the first thing you can do.
Right.
I have a lot of thoughts, mostly because I've been collecting citation metrics on my own stuff for exactly this kind of thing for my internal evaluations. So there are a few things that you can do if the software developers make it easy for you. So oftentimes software will come with a paper. That's how we have traditionally tried to sneak citations in. So you can cite the paper if that's relevant. So Scikit-learn did this. They had a paper in the Journal of Machine Learning Research in 2011, and it had the primary authors at the time. And that paper gets cited. It's got, I don't know, 25,000 citations or something at this point. It's absurd. The problem with that is you're citing something from 2011, and there's been so much work by so many other people that is not getting acknowledged when you cite it in that way. So I'm thinking particularly like Andreas Miller, who's like one of the release managers and does a lot of work on corralling pull requests and stuff. Does not get counted in lines of code very often, but he does a lot of work on that project. It's really hard for him to get acknowledgement. And he's not even on that list of authors. So like, what do you do with that? So what I do with Librosa is we did have a paper that documented the design goals and like the first couple of versions in 2015. And that's what most people cite, even though the paper explicitly says, do not cite this paper, but nobody reads things. What we prefer is every version we release gets archived to Zenodo. When, and this is automatic. You hit the release button on GitHub, it makes a tag, it says, hey, Zenodo, link up, make an archive. You get a new version number. That version number gets a new DOI. If you use version 0.7.2, you cite the DOI for version 0.7.2, and that will have a link to the authors of that version because GitHub keeps track of who all the contributors were. I try to make this easy for people, they don't do it. And that's a particular kind of package, right? You have large packages with a lot of contributors, you have that problem. Most packages are not that. They're small things that have relatively few contributors. They don't change very much over time. For those, what I usually recommend, and I'm biased here, is get the paper published in the Journal of Open Source Software. You don't write a real paper, you write like a one-page description of what the software is. It goes through a vetting process. It gets reviewed by people to say, hey, the software actually has unit tests and documentation. I could install it, it works, da, 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 da. Then that gets archived as a paper, but not like a paper. It's just a DOI that you can cite for that software. And that is a good way to accumulate some level of credit in the traditional mechanisms that are expected by most institutions. I say I'm biased here because I'm an editor for JOS and I have published there before. So please submit your papers to JOS. That's a good thing.
Thanks, Brian. Anna Maria, would you like to add something?
Well, I was just opening this journal, like, oh, I'm gonna take a look here. This is something that we were considering, like for the data, because you have the same problem with the data. Like also Brian mentioned that some data release is hidden in a paper which introduces some method, and then it is not described enough, or it is somehow, you know, like when you write a paper about some method, then you have like a 1 paragraph space for your data, and that does not document it. It's okay, you describe something about it. So I actually do not remember the name of the venue, but also our library was recommending that there are also this kind of like channels for publishing exactly kind of like papers which are describing in detail the data. So then you can have like a proper citation to the data itself without, like, just imagine like, okay, you publish, you write a small description of some data that you are gonna publish, and then you have some method which will be maybe rather, you know, weak, and then you get like tons of citations simply because people are gonna use that data, and this is the first paper where your data appears, you know, and yeah, it ends up in this kind of situation.
Thanks. Let's move on. We have a question by Ricardo on going back to evaluation on the topic of reporting metrics, statistics. Basically, it's sometimes too costly to do because it's too costly to run multiple training runs of the system. Is there a way around this? It's indeed easier to run a small SVM multiple times compared to you know, running a big network multiple times. I guess that's what's suggested here. That has a cost, it consumes time, and it consumes a lot of carbon. So what would be your take on this? Is there a trade-off somewhere?
I totally appreciate that. I currently am doing an experiment where it takes about 6 days to generate my metrics for one fold of one model. It's a pain. I guess the thing to think about is, what exactly are you reporting and why? In the sense of, you know, usually what we care about is expected performance on unseen data. And a test set performance is a proxy for that, right? You sample some data that you haven't seen, you measure your performance on that, and in expectation, that is what you should see when you run it on really unseen data. But there will be error bars on that. So what are you marginalizing over when you do this expectation? It should be the draw of the data. But if you're doing multiple folds, now you're also marginalizing over the choice of the train test split, your random initialization seed, your training procedure, all those other things. And maybe you have good samplings of that parameter space, maybe you don't. But these are the things that you have to account for. This is why we do multiple splits, is to get a sense of stability. So, you know, if you have a big enough test set and you're worried about training performance, or you're worried about how you're going to generalize, you could do like bootstrap sampling on the test set to just estimate how much variance you would get from multiple redraws of the test set. You're not marginalizing over your training run anymore, but you're at least trying to account for the stability of the model on different test splits in a similar sort of way that you would with cross-validation. But, you know, just be cognizant of what it is you're measuring and what you're not measuring when you do that kind of thing. Probably there's no free lunch.
Yeah, I'd agree with that. Do you guys want to add something, Cynthia or Ana Maria? Okay, we're getting close to the end of this nice discussion. So maybe I'd like to ask you whether you guys had a question in mind, something that was not addressed, that you think is important to mention.
I'm not sure if it's a question or rather a remark, but I think a big challenge is for all of us who care about these things indeed to keep very openly caring about this. And let's say looking at us as the people who now have their videos open, we're senior enough to be able to care and to be seen by others, like the people who are listening to us here. And I definitely think that is very important. Again, thinking of open science more than open access types of movements that are around me locally, I've really seen very interesting situations where, for example, my library even tries to have more of an open journal that seems to not just accept papers, but more interactive visualizations and supplemental material and those things. I think it's a really nice idea with open reviews that can be accessible to multiple disciplines, but obviously they need buy-in there. And I really see there that the people who are most enthusiastic about it are PhDs, where many of their supervisors are a bit like, yeah, but you also have that other journal, just go there. So there, I think there is a role to play. And of course, again, you need to trade off with what your students have in terms of their ambitions. I can't fully tell my people, forget about it all and just do these things. I can't do that either. But I do feel there that let's say when I spoke to these people, that they told me, like, yeah, many of these PhDs now support us underground, and I don't think that's cool. So there, some of us need to step up. Many of us, I think, are in good positions for that. Also, more broadly, I've seen in terms of teaching that if we speak about replications of papers, more and more, many people in the machine learning community do that now, have courses that actually have replicating a big paper as a task, which I think is very insightful for people to run into obstacles and figure out how these things really work in practice. So I like those types of setups too. Beyond that, I am still very much puzzling about how to teach and disseminate the best practices in the best way. I don't quite know. As I've raised before, probably here teaching these best practices on how to manage your project, keep it up, have these good practices on creating something that's maintainable in the future, just by a few simple steps. Doesn't need to be the whole circus of it, but just a few practical, basic things. I'm not quite sure we have good starter trainings on that as much as we might have intro courses to Python in general or machine learning in general or those things. So it is something I just wonder about a lot. Like, do we need to also emphasize other skills? Do we need to have more examples on that are shared more? I don't know, but if people have thoughts on that, I'd be very happy to exchange.
Thanks, Cynthia. Indeed, it's an important question. I guess that's you, Ana Maria and Brian. Any thoughts about this?
Yeah, well, considering on I mean, continuing a bit on what Cynthia was saying, I'm sometimes wondering how, because also I started my PhD so a long time ago when it was the same thing. It's like there was some shared folder of our group, and then you just find there some code, and then you just use some bits and pieces. So it was completely different, and it's a bit of a interesting thing how to encourage students to actually do this. It's like you go tell a student, okay, how about if you publish your code, and they go like, oh, what? Like somebody else will use it, and what if they are, you know, like I'm going to be slow writing a paper which will use this, and then what if somebody goes ahead and, you know, they use my idea, or they will end up with some, you know, because I think that ideas develop in a way, many people have the same idea kind of like, and then they start working on it, and then you notice like, oh, these other guys are doing the same thing. So maybe for a PhD student, this is kind of a issue of you know, claiming the code, you know, the method. You know. I think it's kind of like you know, you lead by example, and then you say, eventually you're like, okay, it might happen sometimes that it happened even in the old days that, as I said, some people have the same idea, and then you're just like start writing a paper. Now I have good results, and then you say, hey, somebody else just published this, and you're like, But it happens. But it's kind of like on a longer run, you get this reward. Just need to convince the newcomers that it will happen.
Yeah, and that requires indeed a dedicated, you know, effort when it comes to teaching these things, and this is not happening sufficiently yet, I would say. And so, Cynthia, I fully get your point, of course. Brian.
Yeah, you know, depending on what exactly your role as an instructor is, there are some ways to go about this. Like for example, some of the classes I teach, they're all basically at the master's level. But PhD students take them as well, because we don't really distinguish between those in my university. And some of the bigger project assignments will be like, okay, here's a baseline system. You need to implement this from scratch so you understand how it works. And then once you do that, okay, now you can use the pre-baked thing. It's one version of it. Another version is maybe you want to do you know, an open-ended project, but the first step is reproduce something else. Like read that paper, get those results, and then build off of it. And you know, you have to work closely with students to make that feasible, because they might pick something that's just impossible to replicate, or is just too much effort for a one semester class. But you know, with a little bit of hand holding, it can work. For my more intro level classes, I do things where it's like, okay, here's what a discrete Fourier transform is. Here's the equation. Here's a slow Python nested for loop that does it. Make sure you understand that. Okay, now we have the radix 2 Cooley 2-key version of it. This works for powers of 2. Make sure you understand that. Now here's the NumPy one. Use the NumPy one. But now you've gone through it and you saw how it works. So you can do these things kind of incrementally and locally. But if it's more the level of like a research PhD student getting started, sometimes you just gotta, you know, grin and bear it and just say, okay, your first project is making sure that you can get, you know, that last paper that came out on your topic to work. And then you can make progress. But until they can do that, it's really hard to say, like, just go off and do it.
Yeah, indeed. Thanks very much, all of you. I would like to ask all the participants to join me in giving you a good round of applause. It was nice talking to you. I hope everyone has enjoyed this as much as I did. Well done. And I think I'll hand the mic back to Mathieu for the concluding remarks and for closing this very nice day or afternoon.
Yeah, thank you, Slim, for handling this panel wonderfully. Really warm thank you for all the speaker. Unfortunately, Alexandre couldn't join us. I think the fact that we ended with about teaching how to do things better is a good sign, because that really means that we are headed towards something new and improving. So I hope that most of the audience took some bits and things, and also now are more confident if they want to follow this path. That was the main aim of this workshop. Obviously, everything, the slides and the video, will be put online really shortly, tomorrow, I guess. So if you want to share that to different colleagues, I think that might be relevant. Again, thank you, and I hope that we will be able to see us physically really soon. Bye-bye.
Bye, thanks very much.
That was a real pleasure. See you.